Hello, welcome to 7.6, which talks about quadratic equations, which we've been covering anyway, but today we're going to be solving quadratic equations using what's called the zero product property. And then we're going to use factoring and maybe some applications if there's time. There is time. We're recording. Okay, so first of all, what is a quadratic equation? A quadratic equation is a second degree polynomial with three terms that is of the form ax squared plus bx plus c. Okay, that's what we call a quadratic equation where you have a, b, and c are real numbers, but a cannot be zero. It could be one, but not zero. Okay, then let me introduce to you the zero product property. It looks complicated, but it's really not. Okay, so hear me. So if you have two numbers and the product of them is equal to zero, then either the first number is zero or the second number is zero or both of them are zero, but one of them at least has to be zero. So if this product AB is equal to zero, then either A is equal to zero, B is equal to zero, or both. Okay, so that's really important. I mean, if you think about it, yeah, what number, can you think of any two numbers that are non-zero when you take the product that equals zero? And I'm pretty sure you can. I mean, you can try, but you're going to give yourself a headache. So fine. So why are we talking about zero product property? Because we're going to use it, and this is going to neatly wrap up the rest of the this chapter. So how do we use zero product property to solve a quadratic equation? So when you have a quadratic equation in factored form, note like this one, see here that this is x plus 1 times x plus minus 4 equal to 0. By zero product property, I know that either the x plus 1 is equal to 0 or the factor x minus 4 is equal to 0. So then it's using that, we can solve for x and actually get a solution to the equation. So here we have x is equal to 1 and x is equal to 4. So what's the process? So on the left-hand side, you need to have your polynomial in a factored form, and on the right-hand side, you need to have 0. Then once it's factored, each of the factors can be set equal to 0. And then from then on, it's pretty simple. You just, use, it's a two-step equation, right? So 5n minus 2 is equal to 0. We add 2 to both sides. 5n is equal to 2. Divide by 5, and then we get that the solution, one of the solutions is 2/5. On the other, for the other factor, we have 6n is equal to 1. Okay, divide by 6 to get rid of the coefficient, and we get n is equal to 1 over 6. So those are the two solutions, 2/5 and 1/6. Let's do some more super fun examples. Here we have 3p times 10p plus 7 is equal to 0. This 3p is a factor, so that we set that equal to 0. 10p plus 7 is equal to 0 also. So then divide by 3, we get p is equal to 0. That's one solution. And then the other one, solve for p. And we get that p is equal to negative 7 over 10, or negative 7/10. And that's your two solutions. Now, what if you have something that's raised to the power 2? Remember that an exponent means to multiply it by itself. So it's the same answer, so you don't need to write this twice. It's just going to be what's we call a repeated answer. So you would just say this is one solution and it's 8. All right. Now, how do we solve a quadratic equation by factoring? So at this point, we need to be factoring professionals, right? So you should be able to look at a trinomial, binomial, and see if it's factorable, and then try to factor it using all the techniques that we've been using the past 5 sections. Okay, so here we have x squared plus 2x minus 8 is equal to 0. Remember, this one has, the first coefficient is a 1. So we take the last term and we ask ourselves, what are the two factors of negative 8 that when combined give me a positive 2? So if you thought negative 2 and positive 4, you were right. So then this factors on the left-hand side to x minus 2, x plus 4, and the right-hand side of the equation stays at 0. And now I use zero product property. So x minus 2 is equal to 0, which therefore leads us to conclude that x is equal to 2. And then here you have the other factor, and we get that x is equal to negative 4. Okay, let's try another one. Here we have x squared minus x minus 12 is equal to 0. Okay, 12, negative 12 combines to become negative 1. So if we have negative 4 and a positive 3, this factors to become x minus 4, x plus 3. Okay, zero product property in action. X minus 4 is equal to 0. X plus 3 is equal to 0. So that means that x must be 4 or x and actually negative 3. So we have the 2. All right, let's do a few more. Now these ones, they're not in the form ax squared plus bx plus c is equal to 0, right? They're not. So we need to move it so that it is. So let's subtract minus 13y. This is, oh man, this is not, okay. Minus 13y to both sides and minus 45. Why did I write 44? Who knows? Okay, so on the left-hand side now we have 2y squared minus 13y minus 45, and on the right-hand side we have 0. These do not have a GCF, so let's use AC method. AC, that's going to be negative 90. What are the factors of negative 90 that when combined give me a negative 13? So if you said negative 3 and negative 10, you were correct. Actually, no, that's not right. Because why is this not right? Because negative 3 times negative 10 did not give me negative 90. Okay, fine. That was too easy. So negative, let's see, what are the factors of 90? So we have 45 and 2. We have 15 and 6. We have 10 and 9. What else do we have? We have 16 and 5. We have 30 and 3. Let's see here. 90, let's see, factors of 90. We have, let me just write that out here to the side. We have 2 times 45. And then they both have to be, one has to be negative and one has to be positive. So it's going to be a difference, 9 times 10. We have 3 times 30. We have 5 times 18, that's it. So 5 times 18, so it would be negative 18 and a positive 5. So then we would replace the middle term with, so we rewrite 2y squared minus 18y plus 5y minus 45 is equal to 0. So we're doing a factoring by grouping situation, right? So we have these two and these two. This becomes 2y for the first one. And then we get y minus 9 plus GCF of the second two is 5y minus 9 equal to 0. So finally, putting it all together, our factors are y minus 9, 2y plus 5. That's equal to 0. Zero product property, finally. Y minus 9 is equal to 0, which leads us to y is equal to 9. And then on the other factor, 2y plus 5 is equal to 0. Solve for y. We get 2y is equal to negative 5. Divide by 2. And y is equal to negative 5 over 2. So those are the two equations. So what about this next one? We have 5x squared minus 13x is equal to 7x. Okay, so we need to set it equal to 0. So subtract 7x from both sides. And we get 5x squared minus 20x equal to 0. GCF 5x, that leaves us with x minus 4 is equal to 0. And then that's it. It's factored. So we can go ahead and use zero product property. 5x equals 0. X minus 4 is equal to 0. Divide by 5. X is equal to 0. That's one answer. The other one, add 4 to both sides, and we get x is equal to 4. That's the second answer. And that's it for that. Let's do a few more. So here we have 45b squared minus 2b is equal to negative 17b. Oh, so this one we have to still, this is very similar to the one we just did. So let's add 17b to both sides. So we're setting it equal to 0. We get 45b squared plus 15b is equal to 0. GCF is 15b. We get 3b plus 1 is equal to 0. Now we can use zero product property because this is factored all the way. So we get 15b is equal to 0 and 3b plus 1 is equal to 0. So then divide by 15. We get b is equal to 0 for one of the solutions. And then the next solution, we're subtracting 1 from both sides. 3b is equal to negative 1. Divide by 3, and we get b is equal to negative 1/3. Okay, so now here we have 144q squared is equal to 25. So let's move that constant term to the other side. We get 144q squared minus 25 is equal to 0. What is that? So bonus points, bonus imaginary points for you if you can tell me, or you can tell yourself, what does this look like? What pattern does this look like? Did you say difference of squares? And if you did, give yourself a pat on the back. It doesn't matter where you are. Just give yourself a pat on the back right now. Because yes, 144 is a perfect square, 25 is a perfect square, and they're different, right? So this is going to factor to become 12q plus 5, 12q minus 5, and those are both equal to 0. Zero product property, 12q plus 5 is equal to 0. Let's solve for q. 12q is equal to negative 5. So q is equal to a negative 5/12. So that's one of them. And then the second one, we have 12q minus 5 is equal to 0. Solve for q. We get 12q is equal to 5. So q is equal to 5/12. So one's positive, one's negative. All right. Let's look at this example now. Here we have it looks factored. To be honest, the left-hand side is factored, but the right-hand side is not 0. So we can't work like this. The only time you can use zero product property is if the left-hand side is completely factored and the right-hand side has to be 0, because it's called zero product property. So if there's no 0, you can't use it, okay? So how do we fix that? Well, I'm glad you asked that. So the way that we fix it is we multiply the left-hand side out and then subtract 3x from both sides and make it equal to 0, combine like terms, and then refactor. So let's go ahead and do that. So here we have 3x minus 8 times x minus 1. So x minus 1. And then let's fill in so this is 3x squared. This is negative 3x, this is negative 8x, and this is positive 8. Okay, so this multiplies out to become 3x squared minus 11x plus 8, and that's equal to 3x. So if we subtract both sides from 3, so let me just write that here. So then we need to subtract both sides, subtract 3x from both sides, so we get that 0 that we want on the right-hand side of the equation, leaving you with 3x squared minus 14x plus 8. Okay, fine. Now we can use AC method. So then this becomes 3 times 8 is 24. What's the factors of 24 that add up to negative 14? Okay, well, since it's 24, that tells you that they're both negative. So negative 12 and a negative 2 multiply to become positive 24 and yet combine to become negative 14. So we're going to do factor by grouping. So 3x squared minus 12x minus 2x plus 8 equal to 0. Okay, let's factor by grouping. The first group has a GCF of 3x. That leaves me with x minus 4. The second group, if I take out a negative 2, I get x minus 4. That's equal to 0. Let's go ahead and take out the binomial in common, x minus 4. What are we left with? 3x minus 2. And that's equal to 0. But we're not done. We have to solve. So zero product property. X minus 4 is equal to 0 gives us that x equals 4 is one of the solutions. The other solution is 3x minus 2 equal to 0. We need to solve, right? Two-step equation, boom. 3x is equal to 2. Divide both sides by 3. You get x is equal to 2/3. And that is it for this one, okay? So let's go ahead and do another one for fun. So here on the left-hand side, notice the pattern, k plus 1, k minus 1. Do you recognize that pattern? If you do, if you said, oh, that's difference of squares, again, right, a plus b, a minus b multiplies to become a squared minus b squared. So this multiplies to become k squared minus 1, and that's equal to 8. And then we subtract 8 from both sides. We get k squared minus 9 on the left-hand side and 0 on the right-hand side. The left-hand side is difference of squares again. So k minus 3, k plus 3, k, k. And then zero product property tells us if k minus 3 is equal to 0, so k equals to 3, right? That's one of them. And then k minus 3 equal to 0. I mean, k plus 3, sorry. Then subtract both sides by negative 3, by 3, and then k is equal to negative 3. So that's it. Okay, let's do a few more. Look like this one here. You have 9m cubed plus 100m equals 60m squared. So first things first, set it equal to 0. 60m squared. You get 9m cubed minus 60m squared plus 100m is equal to 0. Do I have a GCF? Well, I can factor out an m to be sure. So that gives me 9m squared minus 60m plus 100. Now, this is starting to smell like a perfect square trinomial, isn't it? Right? This is 3m squared. This is 10. So you should start recognizing it. So if you have 3m squared, 3m, right? That becomes 9m. And then 10 squared is 100. 2 times 3m times 10. If that's 60m, we got it. Okay, great. So then this factors to become m times 3m minus 10 quantity squared equals 0. So then you really only have to use a zero product property twice, right? So m is equal to 0 since that's one of the factors. That was easy. And then the other one, it's a repeat factor. So you just, you only need to solve it once. Okay, so if you have 3m minus 10 is equal to 0, 3m will then equal to positive 10, and then simplify, m is equal to 10/3, and that's it. Okay, this other one, we can go ahead and move things over. Minus 24x squared minus 24x squared plus 18x. I'm just going to write here plus 18x. So then finally, we're going to get on the left-hand side, we're going to get 8x cubed minus 24x squared plus 18x is equal to 0. What's my GCF here? Okay, I notice that each term has a variable of x. I also notice that each of these is divisible by at least 2, right? 2, so fine. So my GCF looks like it's going to be 2x. So then we have 4x squared minus 12x plus 9. Oh, this looks like a different perfect square trinomial again, yes? So then that's going to be 2x minus 3 squared is equal to 0 times the 2x. So go ahead, zero product property, 2x is equal to 0. Well, that just means that x is equal to 0. Whenever you have a constant times the variable and that's equal to 0, that just means the variable must be 0, right? If it's you have a constant other than 0, right? A number, coefficient. So 2x minus 3, anyway, so 2x minus 3 is equal to 0. Solving for the variable gives us 2x is equal to 3, divide by 2, x is equal to 3 halves, and that's it for this one. Then let's do problems, so a couple of application problems, maybe just like one or two. So same thing, we can use these strategies now to solve word problems. Okay, so we need to, of course, understand the problem, read the problem, identify what we're looking for, name it, choose a variable to represent that, translate it into equation, solve the equation using algebra, then we check the answer, and then we can finally answer the question if we would like with a complete sentence. Okay, so here's one. The product of two consecutive integers is 132. Find the integers. So remember, the first integer, so we'll let x represent the first integer. Then the second integer can be represented by x plus 1, right? Second consecutive, because it's immediately after, so it's going to be plus 1. Okay, so then the product of the two, the product of these two is, remember that is translated directly means equals 132. So what do I have here? If I distribute this x on the left-hand side, I get x squared plus x is equal to 132. Okay, I need to set the right-hand side equal to 0. So then I get x squared plus x, I don't know why this, okay, plus x minus 132 is equal to 0. So finally, what are the factors of negative 132 that combine to become 1? Okay, so what do you guys think? So if you said 12 and 11, you are correct. So positive 12 and a negative 11 multiply to become negative 132, but combine to become a positive 1. So I can rewrite this as x plus 12, x minus 11. Then finally, zero product property. So x plus 12 equal to 0 gives me x is equal to negative 12. So that's one of them. The other, x minus 11 equal to 0. Okay, solving for x, I add both sides, 11 to both sides. I get x is equal to 11. Okay, so that's it. And that's it for that one. Okay, let's do another problem. Shh. Yeah, recording. A rectangular garden has an area of 15 square feet. The length of the garden is 2 feet more than the width. Okay, so let's go ahead and let's draw a picture. Pictures are great. Okay, so the area is 15 square feet. Okay, so 15 feet squared. The length is 2 feet more than the width. So if I let the width equal x, so let's say that the width, I'm going to use the variable x to represent the width, but the length, so notice the following, the length of the garden is, so is 2 feet more. What does that mean? I'm going to add 2 to something than the width. What's the width? Width is x. Okay, so now we have width is x, length is x plus 2. The area, what's the area of a rectangle? Base times height, or length times width, right? So area is x times the width is, x times x plus 2, or x plus 2 times x. It really doesn't matter as long as you multiply them. And then the area is 15, so I can write 15 is equal to x squared plus 2x. Okay, and since it's easier in this case, I'm going to make the left-hand side equal to 0. Really doesn't matter as long as one of the sides of the equation has all the variables and the other side has 0, then you're fine. X squared plus 2x minus 15. What are the factors of negative 15 that when I combine them, I get a positive 2? Did you say negative 3 and 5? Because if you did, you are correct. So then x minus 3 factors into x minus 3, x plus 5. Zero product property, people. X minus 3 is equal to 0. X plus 5 is equal to 0. We add 3 to both sides. We get x is equal to 3. We subtract 5 from both sides. We get x is equal to negative 5. Now, let's think for a second. Okay, stop for a second. So we're talking about length and width. That's a distance. Now, currently, to my understanding, and in pretty much everybody's understanding, distance is always positive. It's a measured. We don't say, oh, I'm going to go if you're not talking about direction, then we're just talking about the distance. So we can, cancel out that answer. And so finally, x is 3, so that means that our width is 3, but then that means that our length, which is x plus 2, is going to be 3 plus 2, which is 5 feet, of course, feet. Okay, and then finally, let's use let's do a Pythagorean theorem problem. Recall the Pythagorean theorem. For any right triangle, the sum of the squares of the legs is equal to the hypotenuse squared, right? So if you have a triangle, this is like, right? Amazing. Okay, so now we have this. Justine wants to put a deck in the corner of her backyard in the shape of a right triangle shown below. The hypotenuse will be 17 feet long. The length of one side will be 7 feet less than the length of the other side. So here's a picture. So all we needed to do is just plug it into Pythagorean theorem. X minus 7 squared plus x squared is equal to 17 squared. So here we go. So we need to multiply these out. So x minus 7 squared, remember that's a perfect square trinomial. So first term squared minus twice, so 14x plus the last term squared, 49, plus x squared is equal to 289. Okay, combining like terms and subtracting both sides by 289, we obtain these two combined because they're on the same side. So don't get combining like terms confused with subtracting both sides or moving. Some people call it moving a variable over. These two are on the same side, so I need to add them. So this is going to be 2x squared minus 14x. 49 minus 289 is going to be negative 240, and that's equal to 0. So now I'm going to show you a trick. These are all even. So if I divide everything by 2, this simplifies to become x squared minus 7x minus 120. And 0 divided by 2, of course, is just 0. So now I do, what are the factors of negative 120 that combine to become negative 7? So let's think for a minute. So what are the factors of negative 120? So that's, let's see, 12 and 10. But we know that one has to be positive and one has to be negative, right? We have 20 and 6, right? We have, what else? 20 and 6. We have 30 and 4, 40 and, let's see, how about 5? 120 divided by 5, that gives you 24. Nope. Let's see, 24 and let's see, 120 divided by, that's 30. 120 divided by, let's see here, let's see. 5 times 24, no. We have 20 and 6. We have, what about 8? 8 must divide. 8 and 15, there it is. 8 and 15. So then we need a negative 15 and a positive 8. So then this factors to become x minus 15, x plus 8. That's equal to 0. Let's separate these using zero product property, which we are now experts at. So then we solve for x on both sides. X is equal to 15 is one possibility, and then x is equal to negative 8 is the other possibility. But again, what did we say about negative solutions? When we're talking about real life applications and we're talking about lengths, that we can cancel the negative one. And so then we have that the lengths of the sides of the deck, lengths. One is 15 and the other one is x minus 7. So then, which is 8. So we have 15 and 8. Okay, That's it for this section, you guys. Congratulations. Good luck studying. This is your homework 315 to 347, odd or every other odd. May I suggest that you do odd because solving quadratic equations is something we're going to use for quite a while. So you need to get used to it. Good luck, and I will see you on the next video.